Very good afternoon, everyone. Welcome you all to this NPTEL online course, discussion course on industrial inorganic chemistry. So, I am Madhuri Bhattacharya, Prime Minister Research Fellow in Department of Chemistry at Madras. In this course, we are discussing regarding some important industrial inorganic compounds, their preparation, their purification and utilization. This course has been taken by Professor Devashish Rai from Department of Chemistry, Indian Institute of Technology, Kharagpur. So these are my details. You can contact me over my email IDs for your any queries on this course or any clarification. If you have any question, you can ask in the discussion forum also. I'll try to answer those in the upcoming videos. So we are almost the end of our course. So we have discussed all these compounds, nitrogen, phosphorus, halogen compounds, okay, mineral fertilizers, potassium containing fertilizers, some metallic compounds, and then in the previous class we have covered some alkaline earth metals, alkaline earth materials, some important organosilicon compounds also, some conductors, semiconductor materials we have discussed. In this class we will discuss some more organosilicon compounds, zeolites specifically, and these compounds we will discuss today. So coming to the first question, which among the following reacts with urea to form NN-bis trimethylsilyl urea? So the correct option will be hexamethyl disilazine. This is one compound that will react with urea to form NN-bis trimethylsilyl urea, because urea is NH2CONH2, right? So both this amine group can be reacting with this silane moiety CH3O3 Si. This is the trimethyl silyl unit, and this one hydrogen can be substituted by each silyl can be substituted by actually one hydrogen can be substituted by one trimethyl silyl unit, leading to this one, leading to CH3O3 Si NH2 CO. Okay. And then this NH, this amine will abstract this one proton and one proton, so two proton, and will convert to ammonia. This is the reaction involved by formation of NN-bis trimethylsilyl urea, and this is an important reagent. This reagent, like trimethyl disilazine. This one is very important compound for introducing some protective groups on amine. So this is used for amine protection and as a hydrophobizing agent for filters. It is formed by reacting. How this is formed? This trimethyl disilazine. This is formed by the reaction of trimethyl silane chlorosilane with ammonia. So this is the reaction. Okay. The next question is about which of the following reacts to form methyl tributanoxyaminoxidilane. Okay, methyl tributanoxysilane. Which of the following leads to formation of this one? So the correct option will be methyl trichlorosilane, followed by the reaction with 2-butanoxime. Yeah. So industrially important compound, this one, methyl tributanoxyaminosilane, is formed by reacting methyl trichlorosilane with 2-butanoxime. This is utilized in polymeric chain as cross-linking agents in silicon sealants, and in which acidic reaction are actually undesirable. This means the sealant materials can go further improvement. So the reaction will be like this. Reaction will be actually first methyl chlorosilane, right? CH3 SiCl trichlorosilane. So plus 2-butanoxime, right? Something was written. 2-butanoxime. So 2-butanoxime will be like this. Oxime group NOH. So 3 molecules of this one and 1 molecule of this will react to produce minus 3 HCl will be removed to produce okay. This is actually our 2-butanoximenoxylane. Methyl tributanoxysilane. Methyl is the methyl tri 3 butyl non-oxy oxy linkage is there. Imine linkage is also there, and silane because silicon is there. So this is the compound structure. Then move to the next question. What are the uses of organomarcaptosilanes and organosulfidosilanes? So adhesive promoters, vulcanization additives in rubber industry. So correct option will be both A and B, because sealant is a molecule of one central silicon atom with 4 attachments. And now this attachment can vary combination of the organic or inorganic groups. Sealant linked with sulfur are very much important compounds as adhesive promoters and vulcanization additives in the rubber industries. Now the incorrect statement about silicon among the following is silicons are not stable at high temperature. Yeah, these are actually stable at high temperature. So silicon atoms each linked with one or more organic groups via carbon silicon bonds are linked to another through oxygen atoms to produce straight chain, branched, cross-linked oligomeric or polymeric molecules. These have various properties. Among them, silicons are very stable at high temperature. It is hydrophobic and adhesive also. Silicons are electrically non-conducting. Silicons are gas and vapor permeable. Okay, so silicons actually will have this structure. R is polymer. This is called the silicons. Okay. What does quartz glass consist of? So as we all know, quartz glass means silicon dioxide only, and this is the pure form of silicon oxide without any alternatives, without any additives or impurities. Quartz is a glass consisting of almost pure silica, that is silicon dioxide, in amorphous non-crystalline form. This differs from all other commercial glasses in which other ingredients are added which can change the glass optical and physical properties. So this quartz is the only industrially utilized single component glass. Compared to other common glasses, the optical transmission of pure silica extends well into ultraviolet and infrared wavelengths. That means ultraviolet ray and infrared ray can transmit through pure silica. It will not absorb it. So it is the UV or infrared transparent material. And this is used to make lenses or other apparatus for these wavelengths. Like UV cell cuvette, we will make with pure silica or quartz. So what is the maximum? Next question is about the impurity in the quartz. Actually, the maximum permissible Fe2O3 content for a UV transparent glass. What is the maximum permissible content? That is 0.004%. So the quality of glasses to a large content is influenced by the precision of weighing and proficiency of blending, and the maximum percentage of maximum permissible percentage of Fe2O3 in UV transparent glass is 0.004%. Very mild it is. Then incorrect statement among the following about geolites. Geolites are not crystalline and microporous material. So this is the incorrect actually, because geolites are usually described as crystalline microporous silica based material. So this is commonly used as commercial adsorbent and catalyst. Adsorbent means it can absorb depending on its cavity size, like 3 angstrom, 4 angstrom, 5 angstrom will be its cavity size. Depending on the cavity size, it can absorb one guest molecule. It can serve as a host, and depending on the cavity size, it can bind one guest molecule. So it is acting as a good adsorbent and catalyst also. Like some specific material will be adsorbed, and some solid interface interaction can happen on its surface, so this can act as a catalyst also. The basic unit of geolites are actually SiO4 and AlO4 tetrahedra linked to one another by common oxygen atom. Geolites are widely used as ion exchange beds in domestic and commercial water purification, softening and other applications. So geolites means actually, so geolites, right? Geolites. This is aluminum, silicates, or commonly aluminum silicate mineral that is feldspar. Having general formula some metal Al O2 Sr O2 OLEX dot YH2, and this metal is generally hydrogen and sodium, and the ratio of silica by aluminium ratio. So this actually determines the property of our geolite. For example, if it is greater than 3, then we will call it as high silica geolite, and this will be more hydrophobic. Okay, so that's all about geolites. Okay. Then, what is the shape of inorganic fibers? So, inorganic fibers will have generally cylindrical shape. Because materials from polymers, metal, ceramics having cylindrical shape will be having length is to diameter ratio greater than 1 to 10 to 1, means either same length and diameter, or length will be more, then it will be called a cylindrical shape, and also diameter less than 250 picometer, which are generally produced by particular forming process. Most of the fibers are obtained by extruding a flowable form like a melt or solution. We will extrude of appropriate chemical composition. Then what is the asbestos mineral in serpentine group? Serpentine group will have this asbestos mineral as this chrysotile. Actually, chrysotile is the only asbestos mineral in serpentine group. It is having fibrous habit, is one polymorph of serpentine, and serpentine is basically a particular form of crystal, looks like greenish appearance it is having, and is one of the more important asbestos mineral. Other polymorphs in serpentine subgroup may have a platy habit like antigorite. Other options, antigorite and lysatite, are the polymorphs of serpentine with platy habit, not with this asbestos habit, right? Not with this fibrous habit. Okay. Then what are the factors asbestos properties depend upon? Asbestos type, fiber length, chemical composition, actually all of the above. Because asbestos is a naturally occurring fibrous silate material. It is silate material, but it will be fibrous, like composed of crystals looking like a fiber, long crystals. Asbestos properties can depend on asbestos type like deposit, chemical composition, fiber length, degree of decomposition. All of these factors will influence the asbestos properties. So asbestos fibers are separated from the rock in crust mixture by using a hydrocyclone method, and the longer and shorter fibers are separated with a rotary sieve. So that's all about asbestos silicas and our zeolites, like some organosilicon compounds we have discussed today, quartz, high purity silica, then silicones also. Okay, so that's all for today. Thank you all.